Hello friends, today we'll be beginning with a new chapter. So before that, if you're new to this channel, so please do subscribe and also press the bell icon to never miss any updates. So today I'll be starting one of the very important chapter which will be asked in GATE examination and all the competitive examination. One of the very important chapters in the advanced soil mechanics and foundation engineering, that is lateral earth pressure. Okay, let's begin the discussion. So friends, now let us begin the discussion on the chapter lateral earth pressure. Okay, so to begin with, let us discuss some basic definitions of earth pressure. So what is this earth pressure? It is a lateral pressure exerted by the soil mass against the earth retaining structure. Say for example, if this is the earth retaining structure, okay, or it is also called as retaining wall, okay, whatever the soil mass is exerted in the upward direction, opposite to the retaining wall, it is acting in the lateral direction. This pressure is called as earth pressure. Okay, it is a lateral pressure exerted by the soil mass against the earth retaining structure. Coming to the types of earth pressure, we have two types. Okay, first one is active earth pressure, second one is passive earth pressure. Now let us discuss what is this active earth pressure. So what is this active earth pressure? When the wall moves away from the backfill, say for example, this is the backfill, okay, this is the backfill, the earth retaining structure is moving away from the backfill. That time what happens? There is a certain amount of pressure, okay, that pressure will decrease to some value and that decrease will continue to certain value till the minimum value is reached. And this pressure, when it remains constant, that time the pressure is called as active earth pressure. Okay, this is what is the basic definition. Until this minimum value is reached, this minimum value will remain constant, and that constant, what the pressure is there, that pressure is called as active earth pressure. Now coming to the next part, that is passive earth pressure. It is exactly opposite of active earth pressure. So here if this is the earth retaining structure or else it is the retaining wall, that time what happens? This will move towards the backfill, the wall moves towards the backfill and there is increase in pressure. Pressure will increase to certain value and it will increase to the maximum value. At this maximum value, the pressure remains constant and that pressure is called as passive earth pressure. So friends, this is a schematic representation of active earth pressure and passive earth pressure. Just go through it once. Let us discuss about Rankins theory, its applications, its limitations and all that. So to begin with Rankins theory, soil mass is semi-infinite, homogeneous, dry and cohesionless. The second point says the ground surface is plane, horizontal and inclined. Okay. So this is the plane surface, okay, it is plane, okay, it is plane, it is horizontal, okay, this is horizontal usually and it is tilted, okay, this is inclined. The face in contact with the backfill is smooth, okay, smooth, vertical and friction between the wall and the backfill is neglected, okay. So if this is the retaining wall, what happens? The face in contact with the backfill. So this is the face which is in contact with the backfill, that is smooth and vertical. Okay, it is smooth and vertical. And the friction between the wall and backfill is neglected. So there is friction going to take place here. This friction is neglected. This is what the third point says. Okay. Last, fourth point, what does it say? The wall yields about base sufficiently and for active pressure to be developed. So this wall makes sure that there is certain amount of development of active earth pressure. Okay, for that it yields the base sufficiently. The base is yielded sufficiently. Okay, this particular base is yielded sufficiently in order to develop the active earth pressure. So if the passive earth pressure takes place, the wall is pushed towards the backfill. Oh, if this is the backfill and this is the retaining wall, this is the backfill. Okay, what happens here? The wall is pushed towards the fill. Okay, this wall is pushed towards the backfill. Okay, that time there is the mobilization of passive resistance. passive resistance moves. Okay, passive resistance is developed here. Okay, and this makes sure that there is a mobilization of retaining wall. So this is what the Rankins theory. So what are the drawbacks of this Rankins theory? Okay, initially the first point says it is made up of masonry, concrete, okay, and also cement. So because of that there is certain amount of roughness on the surface. Because of the roughness, what happens? Friction is developed. Okay, this is what is the first point. The second point says, so if the back is smooth, it is not smooth, right? It should, so what happens? Because of that, the resultant pressure should be parallel to the surface, okay? But here what is happening? It is not parallel to the surface. It is moving, okay, against the surface, or else it is moving with respect to surface, or maybe perpendicular to the surface, like that, because the wall is not smooth, the back wall is not smooth. Okay, that time the active earth pressure is inclined in the wall and the angle is equal to the friction. Okay, there is certain amount of friction developed and that angle is equal to the active earth pressure's inclination towards the wall. This is what the second point says. What is the third point? Fill is not vertical. Okay, this is wrong. And in practice, batter is given to the wall back. Batter, that is nothing but certain amount of fill is given to the back fill so that it is not vertical. So this is what the third point says. Discussing about the last point, what it says, the retained soil may not be cohesionless. Okay, it can be having cohesion, it can be having other features also. It may not be necessarily cohesionless, is what the last point says. See, let's start with the discussion of Coulomb's earth pressure theory. It says the backfill is dry, cohesionless, homogeneous, isotropic. It is elastically undeformable but breakable. It is undeformable, it is not possible. Okay, but it can be broken. But once deformed, it cannot be, okay, regained. Okay, that is what the first point says. The slip failure is plane which passes through the heel of the wall. So if this is the wall, retaining wall, and this is the heel of the wall, okay, if this is the heel of the wall, slip failure takes place in the plane which is passing through the heel of the wall. This is what the second point says. If this is the sliding wedge, okay, if this is the sliding wedge, itself acts as a rigid body. Okay, sliding wedge as a whole, we have to consider the limiting earth pressure condition. So what are the different earth pressure conditions we'll be studying in the upcoming modules. Okay, this is the rigid body. Okay, and the value of the earth pressure is obtained by considering the limiting equilibrium of the sliding wedge as a whole. This is the third point. Coming to the fourth point, what does it say? This is the retaining wall. So this is the back. Say for example, if earth pressure is acting in this way at 1/3 height, so this is 1/3 height. Okay, if this is the entire height of the wall, earth pressure acts this way and the angle made here is delta. It is what the fourth point says. Now coming to the fifth point, along the length of the wall, all the conditions of the wall, the fill, they are constant. Okay, they won't change with respect to any of the conditions. This is what is our fifth point. Coming to the last point, what does it state? When the soil wedge is considered at an incipient failure is nothing but when the sliding of the wedge takes place, that is the value is impending. That is what it says. It gives the limiting value of the earth pressure. Earth pressure's least value is obtained when the soil wedge is considered at incipient failure. When the earth pressure makes sure that the retaining wall, there is certain amount of crack or whatever the breakages is available on the structure, that time what happens? There is a limiting earth pressure. So minimum earth pressure is obtained, is what the sixth point says. So friends, now discussing about one of the very important questions that can be asked in exam for nearly 8 marks. Okay, that is earth pressure at rest condition. So there are different conditions for which the earth pressure exists for the retaining wall. In that, first let us study about rest conditions, and later we will even study about the other conditions as well. So initially, to begin with, let us discuss about the earth pressure at rest condition. Here you can see the retaining wall of height h, and what are the forces acting on it, that is sigma v and sigma h, that is, okay, vertical stress and horizontal stress acting on it. Okay, sigma h is equal to k naught gamma z, and p naught is equal to half into k naught into gamma into h square, and the base of the earth pressure diagram is k naught into gamma into h, that you have to remember. And at the place where the horizontal stress is acting, that is z, that is the particular depth at which sigma h acts. Okay, this is the diagram. So sigma is the vertical pressure and sigma h is the lateral horizontal pressure. So these are the different pressures, okay, pressures that are acting on the retaining wall. So sigma is the vertical pressure, sigma h is the lateral horizontal pressure, and k naught is the earth pressure constant at rest condition, gamma is the relative density, h is the height of the retaining wall, and here also same, p naught is the pressure at the rest condition. Coming to the assumptions and what are the earth pressure at rest conditions, what all will happen when the earth pressure is at the rest condition, let us discuss about that. If the wall is rigid and does not move with respect to the pressure exerted on the wall, soil behind the wall will be in elastic equilibrium. So soil behind the wall, so if this is the retaining wall, whatever the soil mass here it is in elastic equilibrium. Okay, this is what the first point says. In backfill with homogeneous nature, so if this is the backfill of the retaining wall, here if there is homogeneous nature, that means all the soil compositions are of same quantity, that time what happens, the sigma v and sigma h will be increasing with respect to z. Okay, with respect to this depth, sigma v and sigma h will also increase. Okay, sigma v and sigma h are directly proportional to z is what the next point says. So sigma h by sigma v remains constant, that is k naught. K naught is nothing but earth pressure coefficient at rest condition. Okay, coming to the next third point, frictionless wall has no shear stress on the vertical and horizontal plane. Okay, if the wall is frictionless, that means if the wall is smooth, that time what happens, there is no shear stress on the vertical as well as horizontal plane. So if this is the horizontal plane and if this is the vertical plane, at that condition there is no shear stress. This is what the next point says. At elastic equilibrium condition, strain remains zero, that is epsilon remains zero. That means sigma h by sigma v is equal to k naught gamma z divided by gamma z. So sigma h is equal to k naught gamma z divided by gamma z. Gamma z and gamma z will cancel. So k naught remains. K naught is equal to mu divided by 1 minus mu. Okay, this is one more coefficient that we got. So now k naught is equal to 1 minus sin phi. Sin phi is the angle made with the horizontal retaining wall. Now k naught also depends on the relative density, that means gamma, gamma of the sand, and it also depends on the deposit and the formation process. So how there is a formation of retaining walls, backfill and other properties, based on that formation it depends. K naught ranges from 0.4, 0.4 is the loose sand, 0.6 is the dense sand. Okay, the tamping of layers may increase up to 0.8 is the rest conditions values. Now let us discuss about the development of active and passive earth pressure. So this is the diagrammatic representation of development of active and passive earth pressure. So this is a curve starting from here and it reaches till here. Okay, at the point where there is intersection taking place, that is the pressure at rest, that is P naught. Okay, earth pressure at rest condition is what is this? Now this distance taking place from the left side, that is delta A is the change in active earth pressure, delta P in the right direction is change in the passive earth pressure. Coming to this point where the initially the pressure curve is going to take place, here PA is nothing but active earth pressure, and here where there is the point where the pressure is constant, at here PP, passive earth pressure, is going to take place here. At intersection there is pressure at rest condition, that is P naught. Initial, when there is a start of the earth pressure, that is active earth pressure. When there is end of the earth pressure, that is passive earth pressure. Okay, this is the curve schematic representation. So Here this is away from the backfill and it is near the backfill. So this one is change in active earth pressure is delta LA upon H, and this is delta LP upon H. Okay, this is what is the change in the active earth pressure. This is the change in the passive earth pressure. Here you can see the constant at active earth pressure is Ka, constant at passive earth pressure is Kp, and at the point of intersection where there is the earth pressure at rest condition, that from this distance till the base, the constant is earth pressure constant at rest condition, that is K0. Okay, so this is what is the schematic representation, delta La by H, delta Lp by H. Coming to the active earth pressure at this particular conditions, we have Ka is equal to sigma H dash divided by sigma O dash. Okay, O is nothing but 0, that is rest condition. So this is here the horizontal condition is active earth pressure, and for this same thing Kp is equal to sigma H dash divided by sigma 0 dash. So sigma H dash is nothing but passive earth pressure's condition. Okay, and this is sigma 0 dash is nothing but at rest condition. So this is what how you have to take the constants into consideration. So this is the development of active and passive earth pressures. Earth pressure coefficients. So first is active earth pressure coefficient Ka. Ka is nothing but horizontal principal effective stress with respect to vertical principal effective stress when the retaining wall moves away from the retained soil. Say for example, this is the retained soil. So when this retaining wall moves away from the retained soil, that time whatever the constant is going to take place, that is called as active earth pressures coefficient. Now horizontal principal effective stress upon vertical principal effective stress is nothing but the passive earth pressure coefficient when the retaining wall is forced against the soil mass. Okay, this is the soil mass and this is the retaining wall. It is forced against the soil mass. That time the constant is called as passive earth pressure constant. Now coming to the earth pressure coefficient at rest condition K0, that is nothing but horizontal principal effective stress with respect to vertical principal effective stress when the retaining wall does not move at all. Okay, the retaining wall is fixed. Okay, here the soil mass is there, it is not moving. That time whatever the constant comes, that is called as earth pressure coefficient at rest condition. Now let us discuss about important thing, that is Kalmans graphical method for cohesionless soil, how to determine the active earth pressure. So this is the diagrammatic representation. This is the retaining wall. Okay, this is A, B, that is surface in contact, which represent the graphical method. So initially we have to draw the line AB. AB is drawn. Okay, now BD is the phi line. Okay, so this is phi angle. So this psi angle is equal to alpha minus delta. Okay, this is L. Okay, PQ is parallel to BL. BL and PQ are parallel to each other. Okay, now the failure plane has to pass through this point T. So the failure plane, this one, it has to pass through point T. So this is how the Kalmans graphical method is represented in a very short form. So this is the schematic representation. What they have done is, initially AB is taken into consideration. We have to draw this line AB. Now BD is the phi line. So this is the phi angle, and this psi is equal to alpha. Alpha is this angle minus delta. Okay, we'll get psi. Psi is equal to alpha minus delta. This is A, P, and this is F. This is the failure wedge. And now we have BL is parallel to PQ. Okay, these lines are parallel to each other. All these lines are equally parallel to each other. And this failure plane F, it has to pass through this point T. So this is the Kalmans graphical representation. Hope you have understood this. So friends, coming to the last topic, that is Rabbans graphical method for determining the active earth pressure for cohesionless soil. Okay, we will discuss this. So this is the schematic representation. This is the retaining wall making an angle of alpha. So this is the phi line. So this is the psi line. This is the triangle formation. Here the side of the triangle is x. It is an equilateral triangle. Okay, there is two triangles here, you can see here. and there is a perpendicular drawn for this, which is perpendicular to LG, that is line CM is perpendicular to LG. This AB is the back face of the retaining wall. With respect to BD, we have to make the phi angle. B and D make the phi angle. Psi is equal to alpha minus delta. So psi is equal to alpha minus delta is what we have done. We have erected the perpendicular CM. A and D should meet at C with this perpendicular erection, that is CM. We have got psi line, we have got K, that is active earth pressure constant. Okay, so this is what we have got. Now with respect to this, we have to make a circular line here like this. Okay, now we also have the other parameters, like we have to join these points. Okay, so we have to make, with respect to this M, we have to make a semicircle like this. So this is how the construction of Rabbans graphical method for the cohesionless soil to determine the active earth pressure. Pa is equal to half into gamma into x square into sine psi. Okay, gamma into CGL. So this CG and L. So this triangle's area, that is what you have considered here. So gamma x into n. N is nothing but the line CM. So this is called as N. Okay. So this is what is the Rabbans graphical method. So thank you for watching this video. So please do like, comment, share and subscribe.